Solid principles gives us 5 principles that we need to follow while writing code. The first principle is single responsibility principle. This principle says that a class should have only one responsibility. In the bad example, we see that the class report has two responsibility. One is of generating report and the other is of printing report, which is a bad design. In the better example, we see that there are two classes, one class report having single responsibility to generate report and another class report printer which have single responsibility to print report. This is a better design as each class has only single responsibility. The second solid principle, open-closed principle, states that classes should be open for extension but closed for modification. This principle says that when we create a class, we should design it to allow extensions, but we should not design it to allow modifications. In the bad example for open-close principle, we see that the class shape has draw method which checks the shape and performs action. If we want to add new action for another shape, then we have to modify the class, which is against the principle which says classes should be closed to modification. In the better example for open-close principle, we see that the shape class has an abstract method draw. This method is then used in subclasses like circle and rectangle. Here we don't need to modify the class shape, we simply need to create an extension of this class and make another class like circle or rectangle and then use the draw method. So this way we follow the rules of open-close principle, which is open for extension but close for modification. The third solid principle, Liskov substitution principle, states that subtypes must be substitutable for base class. It means that if we substitute a subclass with a base class, the program behavior should not change. In the bad example for Liskov substitution principle, we see that class bird have abstract method fly and we see that class penguin inherits the method fly and so it throws an exception as penguin can't fly. So if we replace class bird with class penguin, we see that an exception is thrown and thus a change in behavior occurs which is against the Liskov substitution principle. In the better example for Liskov substitution principle, we see that class bird has no abstract method and we see that class flying bird, which inherits from class bird, has an abstract method called flying bird. So in this case the class penguin will inherit from class bird and this time it will not throw any exception as penguin can't fly because the abstract method flying bird is not present in the class bird. Now if we replace class bird with class penguin, we won't be getting any exception and thus the behavior does not change, and so we have included the Liskov substitution principle in our design. The fourth solid principle, interface segregation principle, states that a class should not be forced to implement interfaces it does not use. In the bad example for interface segregation principle, we see that class printer has both methods print and scan. Now the class simple printer inherits both method print and scan, but class simple printer can only perform print work, but since it has to inherit scan method, the class simple printer will throw exception for scan method. This is bad example as class simple printer should not be forced to inherit method scan. In the better example for interface segregation principle, we see that we now have to separate classes printable and scannable. Since we have two different classes, the class simple printer will now only inherit the class printable and hence it is not forced to inherit the unnecessary class scannable. Since class simple printer can only do print work and it does not do scanning work, this way we include interface segregation principle in our design. The fifth solid principle, dependency inversion principle, states that high-level modules should not depend on low-level modules. Both should depend on abstractions. It means that we should decouple the data access logic from the business logic. In the bad example for dependency inversion principle, we see that there are two classes, database and report. Here we see that the report class is creating an object of class database, and hence it is tightly coupled to the class database, which is against the dependency inversion principle. In the better example for dependency inversion principle, we see that we have class data storage, which has one abstract method save. The class database is a subclass of data storage, and hence it is inheriting the save method and also performing the save task. We also see that class report is getting the object data storage from a constructor, and it is then using the object data storage, which has save method to save data. So here the database logic and business logic is decoupled.